Hi everyone, this is Mrs. Vittles. I'm going to go through lesson 1.3 day 1, which is solving 1 and 2-step equations. Before we get started with the lesson, I'm going to go ahead and go over the warm-up. So for number 1, it says solve each equation. So it's 5 times x equals 100. With simple equations like this, you can look at it and say, okay, 5 times what number equals 100, right? Well, 5 times 20 equals 100. So we know x equals 20. As we get to more difficult equations, it's going to be important that we can learn the steps needed to solve for our variable. So really, 5 times x, in order to isolate that x and get it by itself, we're going to divide both sides by 5. 5x divided by 5 is 1x, equals 100 divided by 5 is 20. Always remember that you can check your answer or your solution to see if you did it correctly. So, sorry, I'm trying to draw some dots there. So 5 times 20, does that equal 100? 5 times 20 is 100. 100 equals 100, and I know that solution is correct. Looking at number 2, x divided by 3 equals 17. In order to undo that division, I'm going to multiply both sides by 3. 3x divided by 3 is just 1x. Those 3's end up canceling out. Equals 17 times 3, 51. It's going to be important too that we stay organized as we go through and start solving equations today. Looking at the next slide, combining like terms. So in order to correctly solve equations, we need to make sure that we are simplifying both sides of the equal sign before we start moving things from one side or to the other. So we need to make sure that we know how to combine like terms and what like terms are. So let's go ahead, and the first thing I'm going to write is the definition. Let's see here. The definition of like terms are terms whose variables and exponents are the same. Terms are variables and exponents that are the same. All right, let's see if I can move that up a little bit. Sorry, you guys, I'm not the most, there we go, savvy with this. Okay, so again, like terms are terms whose variables and exponents are the same. I'm going to go ahead and give you some examples in a minute. One thing to make note of is the coefficients can be different. All right, so down here, I'm going to go ahead and give you some examples. I'm going to go ahead and write these out. So for some examples, 7x, x, and negative 2x are all like terms. So you take a look at the variables. These are 3 separate terms. So 7x is a term, x is a term, and negative 2x is a term. Terms can be a single number, they can be a variable, or they can be a combination of numbers and variables. Okay, another example of like terms are 2xy squared, negative 3xy squared, and negative 1/3 xy squared. Okay. I remember my teacher in high school had said you can think of it as a last name, right? If they have the same last name, which is xy squared, xy squared, xy squared, those can be combined and simplified. I'm going to go ahead and use red. An example that is not like terms would be 4x and 3x squared. So you take a look at this. The x's are the same, right? But their exponents are not the same. So those are not like terms. So if we take a look at this first example here, I like to stay organized and kind of mark what I am going to go ahead and combine. So it looks like, first glance, I have some x's, I have some x squareds, and then I just have single numbers, right? So I have negative 4x squared, 2x squared are like terms. So negative 4x squared plus 2x squared simplifies to be negative 2x squared. Negative 2x, I'm going to go ahead and underline that twice, minus 4x minus 15x. Those are all like terms. That's a total of what? Negative 21x. So I have negative 2x squared minus 21x. Lastly, I have positive 3 plus 5 plus 11 minus 15. Combine all of those, and I am left with positive 4. When you're done simplifying and combining all your like terms, check your solution just to make sure there are no other like terms and it can't be simplified anymore. And if that's the case, go ahead and circle or box your final solution. Okay, I'm going to go ahead and go to the next slide. We have one more example of combining like terms. So taking a look at this, just examining what I'm working with, right away I see, this minus and negative becomes positive. I'm also noticing, if you take a look, I have one xy here. So the coefficient in front of xy is like an invisible 1 in front. I have positive 2xy minus 3yx. This is actually equivalent to negative 3xy. So these three are all like terms, okay? 1xy plus 2xy gives me positive 3xy minus 3xy. These actually end up canceling out, right? They all add up to be 0, so they cancel. 1x plus 2x minus 3x. Again, I have 1x plus 2x minus 3x is 0. So these end up canceling out as well. Negative 9 minus 2. And then I have my plus 4 gives me negative 7. Okay. Again, please make sure you are staying organized. If it works out and you have notebook paper or paper out in front of you to show all your work and make sure if that's easiest for you, please use your resources and try to stay as organized as possible. So those are the examples of combining like terms. In the problems that we're going to be doing today, they're just 1 and 2 step equations. So we're going to combine like terms when we get to more difficult equations. But let's go ahead and look at example number 3. So this is actually the beginning of solving equations, right? X plus 5 equals 11. Now the goal of solving equations always is to isolate your variable. Okay. That means get the variable by itself. So if I have x plus 5, I want to get x by itself. Right now, 5 is being added 2x. So I'm going to undo the operation of addition and go ahead and subtract 5 from both sides. You're going to want to start staying very organized with solving, kind of like what Mr. Laudermilk said. I know some of us, like a first instinct might be to write above the equation. We really want to try to make our answer be almost funneled. So you're going to show all your steps here, make them one right under the other. So anyone that takes a look at your equation can look at and read exactly what you did to solve that equation. So right here, I have x left on the left-hand side. 5 minus 5, that actually cancels out, equals 11 minus 5 is 6. Don't forget, what's nice is you can always go back and check that solution to make sure it is correct. 6 plus 5 does equal 11, and I know that I did this problem correctly. Next problem. At any point, please feel free to pause this video, try these by yourself, and then go ahead and start the video again and check your answers. So negative 2x minus 1 equals 9. You kind of think of an equation too as like a balance beam. What you do to one side, you have to do to the other side. My goal again here is to get x by itself. Okay, my first step is going to be to add 1 to both sides. I'm left with negative 2x. My 1's cancel out, equals 9 plus 1, 10. So I have negative 2x equals 10. So right now, negative 2 is being multiplied to x. In order to get rid of it, I'm going to undo that multiplication and divide both sides by negative 2. Negative 2x divided by negative 2, I'm left with x. 1x equals negative 5. So my solution is x equals negative 5. All right, number 5. This gives us, looks a little different, right? So in this example, we're going to have to use the distributive property first. So outside of this parentheses is really an invisible, it's a negative sign, right? But there's an invisible negative 1 right here. And we need to go ahead and distribute that negative 1 to every term inside of the parentheses. So negative 1 times x, negative 1 times 2 equals 18. So I have negative x minus 2 equals 18. So again, my goal is to get x by itself. So I'm going to go ahead and move this negative 2 to the other side. I have negative x, that cancels out, equals 20. Okay, x is not by itself right now. Right now, negative 1 is being multiplied to x, and I need to get rid of that negative 1 to isolate x. So right now, what I'm going to do is divide both sides by negative 1. Negative x divided by negative 1 is positive x, equals 20 divided by negative 1 is negative 20. X equals negative 20. Last problem. One thing I want to go over that I noticed in these examples is your variable is not always going to be on that left-hand side, and that's okay. So if you got a problem that was 6 equals 2 times 3 minus x, and the variable just so happens to be on the right-hand side, it's totally okay. You're just going to solve it the exact same way you would by isolating x, moving things to the other side in order to solve for x. So for number 6, I'm going to go ahead and use the distributive property first. So I have 2 times 3 is 6. 2 times negative x minus 2x equals 6. I'm not going to distribute that 2 all the way to the other side of the equal sign, right? I'm only distributing to what's inside of the parentheses. Now I want to get x by itself. I'm going to go ahead and subtract 6 to both sides. I'm left with negative 2x, that cancels out, equals 6 minus 6 is 0. In order to get x by itself, I'm going to go ahead and divide both sides by negative 2. Negative 2x divided by negative 2 is just x. 0 divided by negative 2 is 0. Can a variable equal 0? Yes, it can. And again, just to go ahead and show you, you can always go through and check your solution. So 2 times 3 minus x equals 6 was my original problem. 2 times 3 minus 0 equals 6. 2 times 3 equals 6. Remember, I'm checking, is this correct? This is a question mark. 6 equals 6. Ooh. And I always like to put a little check. Yep, I am correct. So just to kind of wrap up, our goal is to isolate the variable, right? So get our variable by itself. Please try to stay organized. So no more division symbol. We want to use that fraction bar with division. Keep everything underneath the equation step by step, and always go back and check your solution to make sure that you solved the problem correctly. Now you can go ahead and move on to your day 1 homework. Thank you for tuning in, and have a great rest of your day. Bye, everyone.